and they are placed at 4. So mass M, M, 2M, 2M placed at 4 corners of a square, students. They're placed at 4 corners of a square, students, of side A. The center of mass of the system is, students, the center of mass of the system is, I'll give you the options, students. A by 2 comma 2A, B, A by 2 comma A, C, A by 2 comma 2A by 3, and option D, A comma A by 3. Students, is the question clear to all of you? Students, is the question clear to all of you?
Yes.
4 masses मैंने दिया है M, M, 2M and 2M are placed at 4 corners of a square of side A. I want you to locate the center of mass for the given system, students. One who please knows the answer, you can text me and then you can answer for it. Yes, anybody? Saud, you are incorrect. Sneha, you are correct. Yana is correct. Janani is also correct. Four students have given the answer. 3 are correct. South, for this you have to attend lectures, my dear. Khyat is also correct. Come on, what about the rest of them? Sanjana, Suhani. Suhani is also correct. Sanjana, why are you so late?
Yes, Sohan.
Aditi, what about you?
Can I just send you the answer?
Okay, fine. Parthui, what about you? Om, Udit, Shreyash. Aditi is correct. Parthui is correct. Vidhi is also correct. Good. What about guys? What about y'all? Sanjana, still I'm not able to get you. Yes, Sanjana, are you getting the answer or not?
Yes, sir.
What's the answer?
So the C option.
Absolutely correct. Answer is C. Shreyash, Udit, and Om. Shreyash, Udit, and Om. Anybody can give an answer, Shreyash? Can you give me the solution for it, Shreyash? Udit, Om. Very good. This is what it is, students. Guys, why can't you all get it in that case? It's such a simple question. Students, abhi bhi tumhe, okay, Yana, can you answer Yana for this?
Yes.
How to solve it? Bolo.
Sir, first we'll write coordinates of all the four particles.
Okay, and how are you aligning these four particles? In
I
an
have put
XY plane?
yes.
Absolutely correct. And how are you locating these particles? Are you going to place it anyhow or in a particular manner?
I have placed mass m at 0, 0.
Okay,
The second one mass m at a, 0.
okay,
2m at
fine,
a, a, and
fine,
the
fine.
other one at 0, a.
Then you should got the, are you getting the answer a by 2 comma 2a by 3 or 2a by 3 comma a by 3?
I got a by 2, 2a by 3.
Okay, and what exactly you have taken? You have taken the mass over here, m over here or 2m over here on y-axis.
I have taken m on x-axis.
Okay, you have taken m on x-axis, we consider. Okay, now students, ध्यान से सुनना, irrespective of your this part of it, students ध्यान से सुनना, जब भी masses को locate करना है ना, students, please try to see to it that you try to place the mass in anti-clockwise direction. Okay, you try to go in that manner. Doesn't matter whether you can go for clockwise or anti-clockwise, you'll get the answer in that case. You don't have to worry about it. Now let us take, now suppose she has taken an M over here, I'm taking an M over here. Doesn't matter. But try to go in an order. Please do not try to change the order. First, second, third, fourth. So third wala third ही होना चाहिए. Are you getting it? It should not be M to M, M into M. Are you getting this thing clear to all of you all?
Yes, sir. Yes, sir.
Place it clockwise, place it anti-clockwise, doesn't matter. Okay, but it has to be in a flow first, because the four particles 1, 2, 3, 4 we consider, because at times यहाँ पे तो masses are in that case, whereas the distance is same. Maybe there might be difference in the distance in that case. So you have to be taking care in that case. Now this is m, I'll consider, let us say the other mass I'm taking it, this will be 2m. Let me take this as 2m. Now what are the coordinates I'll consider? This will be x1, y1. This will be what? Sorry, it's 0 comma a. This is x2, y2. I'll consider this as my first particle. This is my second particle. This is my third particle, and this is my fourth particle. What about the coordinates of this? We consider will be a comma a. It's a square. So this is x3, y3, and over here will be a comma 0, and that will be x4, y4. Students, did you get this? Om, Shreyash, Udit, समझ में आ रहा है? Guys, हाँ या
Yes, sir.
ना? थोड़ा जोर से बोलो यार. Now can you find out the center of mass for the system? Yes, you have to find out xcm and ycm. What is the formula for center of mass with respect to x coordinate we consider as? What's the formula?
M1 x1 plus M2 x2 plus M3 x3 plus M4 x4 upon sum of all masses.
Very good. She speaks so strictly, na students, है ना? वो लेक्चर में भी बैठते हैं तो डराती है, पता है स्टूडेंट्स, ना M1 plus don't laugh. Okay, so what exactly center of mass? ना MCQs आ रहे हैं कि नहीं आ रहे हैं सर्कुलर मोशन के?
हाँ हो गए हो.
Okay, very good. Now see, M1 x1 if I have to consider, so what exactly will be 1 into x1, so it's 1 into 0 plus M2 we consider as what? Sorry, this is M only, simply M. This is M into x2. X2 is equal to how much? Again, this is 0. Okay, plus M3 into x3 plus M4 into x4 upon summation of all the masses m plus 2m plus 2m. So 4 and 2, 6m. So what exactly your xcm I'll consider will be? So what exactly your xcm will be?
4MA upon 6M.
4MA upon 6M.
6M.
Cancellation, what is my answer I'm getting? 2a by 3.
Yeah.
I am.
Yes.
Students, see, if you look over here, I have got xcum as 2a by 3. Are you getting it?
Yes, sir.
And when this is when I took m over here. And Yana, did you get placed m on y-axis or you took m on x-axis?
M on x-axis. I got A by 2.
Yes. Students, कुछ समझ में आ रहा है? पार्टिकल्स को अलाइन करना है स्टूडेंट्स, तो हमेशा ही ध्यान में रखना, जब भी तुम मल्टीपल चॉइस क्वेश्चन करते हो तो तुम्हें कोऑर्डिनेट्स मिलेंगे x, y, y, x. फाइंड इट आउट, डजंट मैटर, योर आंसर विल बी सेम. यू कैन मार्क योर आंसर एज दिस इटसेल्फ ओनली. अगर मैं YCM फाइंड आउट करूंगा तो दैट विल बी इक्वल टू हाउ मच? इट विल बी a by 2. But when you are trying to align the particles, students, what is the formula for YCM? Yana, what is the formula for YCM? Yana, formula?
Sir, it is M1 y1 plus M2 y2 plus M3 y3 plus M4 y4 upon sum of all masses.
Absolutely correct. And this is algebraic sum of all the masses, and all the masses will be 6m. Now when you start solving this part of it, this will be 0 itself only, m into 0, because it will be 0, y1 is 0, plus m2 y2. M2 y2 will be equal to what? M into a, plus m3 y3 will be equal to 2m into a, plus m4 y4 will be equal to again 0 upon 6m. This is 2 plus 1, 3. So what's my answer? Will be equal to a by 2. And students, if in case if I consider my YCM as a by 2 x's, yani ye kabhi hoga malum hai, if in case if I try to go for clockwise. Yani students, when you're trying to align the particles, try to align the particle in anti-clockwise. हमेशा ये ध्यान में रखना, ये पैटर्न तुम रखना, कोई प्रॉब्लम नहीं, you'll be able to get it. अगर तुमने clockwise रखा तो भी कोई प्रॉब्लम नहीं, you'll get the same coordinates. Don't get confused with this, students. Please everybody listen carefully. शायद किसी ने ऐसा ट्राई भी किया होगा, यहाँ पे रखा होगा, तो उनको ये मिला, फिर वो चेंज भी करके they'll try to go for the other way around. So don't get worried in that case, students. It's only that the coordinates will get interchanged. But don't interchange the masses. अगर मैंने first mass यहाँ पे दिया students, तो first mass के बाद में second position कहाँ पे आता है? या तो इधर होगा या तो इधर होगा. You can't take your second mass over here. Do take care of that. अगर वो ले लिया तो एक भी आंसर मैच नहीं करेगा तुम. क्या ये क्लियर हुआ सबको?
Yes, sir. Yes, sir.
ये हमेशा ध्यान में रखना. That is why maybe it's a question which is easy for most of you all, लेकिन please understand it very clearly. Are you getting it? अभी यहाँ पे तो मैंने एंटी क्लॉकवाइज के हिसाब से मैंने ये आंसर दे दिया, लेकिन अगर तुम्हें ऑप्शंस में 2a by 3, a by 2 होता तो that would have been your answer. If in case if I go the other way around. So that depends on to how exactly you've kept it. But try to align the masses in a proper order we consider. Can't change the order, okay? Okay, can I erase the students?
Yes, sir.
Next question. Next one. Three particles each of mass m. Students, now the question is, three particles each of mass m are placed at corners of a right angle triangle as shown. Now I'm drawing the triangle for you, students. Three particles each of mass m are placed at corners of a right angle triangle at point O. This is A and this is B. Since I wanted to find out the position of center of mass for this one. Next question after this, students. I'm giving you one more question, students. Three particles each of mass 1, 2, and 3 are placed at three corners of an equilateral triangle. So 1 kilogram, 2 kilogram, 3 kilogram placed at three corners of an equilateral triangle, students. Okay, of side 2 meters. I want to find out center of mass of system. Students, the system consists of three particles. Are the two questions clear to all of your students?
Yes.
Students, क्या ये दोनों question clear है?
Yes, sir. Sir,
Okay, please answer. Yeah.
sir, in the second question, the side is 2 meters in length.
Yes. Yes. The side is 2 meters. Sanjana has got the answer. Sanjana, where did I give you? Achha, that was the previous. Friends, I wanted to give you the final answer for this one. For the first one in terms of unit vectors, friends. Location of center of mass in terms of unit vector. So I've given you this part. I wanted to locate the center of mass with respect to unit vector. Three particles are placed at three corners of a right angle triangle, M. The sides are given to you. I wanted to find the center of mass for the given system we consider, but I want in terms of unit vector. I repeat. इसके लिए मुझे unit vector की जरूरत नहीं है. यहाँ पे three particles are placed at three corners of an equilateral triangle, side to meet. Locate the position of center of mass. Adarshini, why are you so late for the lectures, Adarshini?
Sir, sorry, I thought it was Saturday today and I saw the lecture of 4:30 timing.
But Saturday I don't have the lectures, my dear.
Yes, sir, I did not check the timetable properly. So I thought it was from 4:30.
Okay, fine. Suhani has got the answer for this one, and she is absolutely correct, it seems. Okay, she's correct. Suhani is correct, the position of center of mass. For the first one, she's correct in terms of unit vector.
Sir, second one in what form do we have to write?
I want in coordinates form. No need to go for unit vector. वो तो जो coordinates आएगा वो तुम एक I और J में लिखोगे और कुछ नहीं होगा, है ना? सुहानी.
हाँ सर, समझा.
मतलब अगर तुम्हें coordinates मिलता है, suppose अगर मुझे इसका आंसर आता है -1 2, हेलो, -1 2 आएगा तो I cannot add -I and plus 2j. Sorry, -I comma 2j. That's what it is. Doesn't matter. So you can add it simply in terms of coordinates. Khyati has also answered it correctly. Good. Khyati is also correct. Yes, come on, the rest of them. Aditi, come on, answer. Janani, Parthvi, Sanjana, Soumya, Sona. Yana, what about you? Oh. Okay, correct. And Suhani has got the second one also. Second one, are you sure, Suhani?
Sir, I think so. This is.
Cross check it, Suhani. It seems that you are in a rush. थोड़ा सा घाई कर रही है तू. Okay, friends, can anybody give me the answer for the first one? Chalo, let's go for the first one. Anyone who wants to answer for the first one? Students, why you are struggling in that case? So what if I've given you a triangle, students? Why can't you take this as your y coordinate? और ये तुम्हारा x coordinate हो गया, खत्म हो गया. Students, इसके यानी ये origin पे ले लो ना, तो ये 0,0 ले लो. ये क्या होगा? 0,b, है ना? और ये क्या होगा? इसकी तो जरूरत नहीं है, इसकी कोई जरूरत ही नहीं है. Students, I don't need this part at all. ये क्या होगा? Students, this will be what? A,0. That's all. Now what exactly XCM? Center of mass we consider is it's M1 X1 plus M2 X2 plus M3 X3 upon M1 plus M2 plus M3. Addition of all the three, all are same mass. Is it along x-axis? Yes. So this has to be in terms of I. What's my answer for XCM will be? Sir, MM will get cancelled. So can I say 1/3 AI? Yes, Sanjay, absolutely correct. अभी YCM क्या होगा तुम्हारा? What exactly YCM will be equal to? M1 Y1, so M into 0 plus M2 Y2 M into B, J cap. Agreed? And plus M3 Y3 will be 0 upon 3M हो जाएगा students. MM will get cancelled. So can I say this is B by 3J? So my first answer, your XCM comma YCM will be equal to how much? 1/3 AI comma BJ. Agreed, students?
Yes, sir.
Students, क्या ये clear हुआ सबको? Coordinates for center of mass for this part? Sneha has given the answer. Okay. South, you're absolutely wrong, my dear. Can I erase this, students? Can I erase this part?
Wait for a
Can I
few
erase this?
seconds. So just a few
Okay.
seconds.
Okay.
Sir, now you can erase this.
Okay. Khadi, Jalan, you didn't get this award.
No, sir. I don't. I think I made some mistake in the.
हाँ, तो एकदम इजी था. शायद मैंने जानबूझ के डायग्राम ऐसा दिया है, यू गॉट कंफ्यूज कि ये सब क्या दिया है. बट द कंसेप्ट रिमेन्स द सेम. स्टूडेंट्स, कभी भी सेंटर ऑफ मास अगर करना है तो उसको कोऑर्डिनेट एक्सिस पे ले लो, खत्म हो गया. जो कंफर्टेबल कोऑर्डिनेट एक्सिस तुम्हें लगता है तुम ले सकते हो. अभी ये वाला देखो. शैल आई सॉल्व फॉर द स्टूडेंट्स? इसका सॉल्व करूं मैं?
Yes, sir.
Students, now I'll give you those students who haven't done it, because many students are not getting it proper, students, for this. I'll draw the diagram for you all properly, students, and then you solve it by yourself. Formula क्या होगा? Before going for formula, let us understand the diagram part of it. There are three master students, 1, 2, and 3, are placed at three corners of an equilateral triangle. So what do I do, students? I'll try to draw an equilateral triangle. All sides are equal, and there are three masses. Now it depends on to you how do you want to look at the masses. Shall I take in this direction or this direction? But it has to be one after another. And in this case, one after another, it's a triangle. It will be a triangle, so anyhow you can consider. So let me take this as 1 kilogram. I'll take the second one. I'll consider if in case if I try to go anti-clockwise, or if I want to go for clockwise, doesn't matter. I'm getting it. My answer will change accordingly. I'm getting it. Suppose अगर मैंने यहाँ पे 2 किलोग्राम लिया तो मेरा आंसर चेंज हो जाएगा. अगर यहाँ पे लूंगा तो आंसर चेंज हो जाएगा. Now, students, those who have given the answer, have you all taken 2 over here at the vertex, or this is A? This is B and C. Where exactly 2 you have taken at point C, students?
C.
Yeah.
C, sir.
Have you all taken 2 kilograms at point C?
Yes.
Yes, sir.
Yes, sir.
Let's go for this 2 kilograms, students. Okay, so your answer will be certainly correct. Coordinates are different in that case. तो तुम्हारा ये जो पॉइंट ए कितना होगा 3 किलोग्राम ना. इट्स एन इक्विलैटरल ट्रायंगल, ऑल साइड्स आर इक्वल स्टूडेंट्स. अभी हम क्या करते हैं, किसी एक पॉइंट को हम ओरिजिन पे लेते हैं स्टूडेंट्स. आई गेट इट. तो मैंने क्या किया, यहाँ पे मैंने एक एक्सिस ड्रॉ कर दिया स्टूडेंट्स. ये तुम्हारा एक्सिस हो गया. एग्रीड. ये तुम्हारा y एक्सिस हो गया और ये तुम्हारा x एक्सिस हो गया. ये पॉइंट C हो गया स्टूडेंट्स. Now when I want to locate the coordinate students, the side is given to us how much? 2 meters students. So now if I happen to drop a perpendicular bisector from the vertex onto the opposite base, okay students, let me take this as point M. This is origin. I'll consider students, it divides the base into 2 equal halves. Agreed. So this much is entirely is 2 and this much is 1 students. Is this 60 degree in an equilateral triangle? Yes. Side is 2. Students, what about the altitude AM? What is altitude AM? अगर तुम AM को locate करोगे students, what is AM? It's a side opposite to 60 degrees students. Students, what is side opposite to 60 degrees? Is √3 upon 2 times the hypotenuse. If I say √3 upon 2 times the hypotenuse is 2. So what is the value of AM? √3. क्या ये clear हुआ?
Yes, sir.
Now can you get the coordinate students? Agar if I happen to go for 1 kilogram mass, which is my M1, I'll consider students my 0, 0 will be the coordinates, x1, y1 will be the coordinates students. Agreed? Agar मैं इसको इनको लेता हूँ, then what exactly my coordinates over here will be? So this will be 2, 0. So this is x2, y2. Agreed? If I happen to go for this as my M3 as my third mass, what about my coordinates will be over here? So my x
1,
coordinate will be
√3.
my y coordinate will be how much? 1, √3. Agreed students? X coordinate is 1 and y coordinate is √3. So what will be? This will be x3y.
Sir, I also
Now,
did the same thing.
yeah. So maybe the coordinates, because I had picked up 1, 2, and 3. And you've picked up 1, 2, and 3 in anti-clockwise. That's what there'll be difference in the coordinates taking into account. Agreed. So it doesn't matter in that case. Now let us solve for this. So what exactly my XCM का formula क्या होगा students? X center of mass will be equal to M1 x1 plus M2 x2 plus M3 x3 upon M1 plus M2 plus M3 students. So what exactly XCOM will be equal to? How much is M1? M1 x1. So this will be 1 into 0 plus M2 x2. So 2 into 2 plus M3 x3. 3 into 1 upon addition of all the masses will be how much? 1 plus 2, 3, 3 and 3, 6. So what's your answer? This will be 4 plus 3, 7 by 6. Did you all get 7 by 6 students?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. That is 7 by 6 I cap. अगर मैंने unit vector में लिखा तो agreed.
Yes.
Yes, sir.
If I happen to go for YCOM, then what will be? It will be M1 Y1 plus M2 Y2 plus M3 Y3 upon M1 plus M2 plus M3 students. So what exactly your YCOM we consider? M1 is going to be it's 1, Y1 we consider is 0 plus M2, Y2 0 plus M3 is 3, Y3 is √3 students upon summation of all the masses 1 plus 2 plus 3, that becomes 6. So this becomes 0 students. This is 3 √3 by 6. 3 2s are. So what's my answer? √3 by 2 J. Is that clear students?
Yes, sir.
How many people have got these as a coordinates? Just raise your hands. How many people have got these as the coordinates? I want to see how many hands raised. Suhani, Pathvi, Janani, Sneha, Sanchana, Khyati. Good. Meera, what about you? Sona, what about you? Yana, what about you? Yana, तुमने क्या mistake की?
I've done something else only.
हाँ?
I have done something else only.
Why ऐसा क्यों? और students, अगर मैं suppose इसको 1, 2, 3 लेता तो मेरे coordinates अलग आते. Again, I would have got different coordinates in that case. यानी students ये try and error भी होगा, ये भी ध्यान में रखना. क्योंकि अगर students तुम्हें जो option से match कराना होगा ना, listen carefully. When they give you certain problems to match up with the option, they will make it very clear. They will make it very clear that ABC is an equilateral triangle. A is 3 kilograms. Because whenever you go for ABC, so students look at accordingly in that case. So you try to work out in either ways, is it matching up? So ये थोड़ा सा try and error वाला हो सकता है students, to take care of that. And now where did you go wrong?
Sir, actually, I found out the components of the two for the
Which one?
third mass. Where A
इसके लिए
is it?
why?
हाँ मैंने.
Why components कैसे आएगा इसका?
So उसका x coordinate और y coordinate मिल गया उससे.
X coordinate, Y coordinate, that means you picked up in terms of cos and sine.
Yes.
Okay. Fine, that is what you can consider, doesn't matter, because that's what you got it as √3 and this one you got it as 1 itself only. लेकिन उसके बाद में you must have got the same coordinates ना, coordinates में तो फर्क नहीं हुआ रहेगा. फिर कहाँ पे गलत गए? Substitution में क्या? हाँ ना?
Because I have taken √3/2 and not √3.
अरे लेकिन ये AB के तुम coordinates निकालते थे ना? 2
हाँ.
cos 60 आएगा ना? 2 cos 60 आएगा ना?
हाँ.
And 2 cos 60, तो 2 cos 60 is half, तो ये 1 आएगा. और 2 sin 60 क्या होगा? √3. हेलो, ये तुम्हारा 2 sin 60 होगा, ये तुम्हारा 2 cos 60. What is sin of 60? √3/2.
Yes.
तो ये √3 हुआ ना, है ना? This is the rectangle, ये दोनों congruent होगा. 2 cos 60, ये आंसर तुम्हें 1 मिलेगा. Agreed? या ना? Agreed?
Yes, sir.
Okay, यहाँ पे गलती की है तुमने. That's why. Okay, students, can I erase the students? इसको erase कर दो अभी मैं. Students, can I erase it now?
Yes,
And
sir.
do keep in mind, students, in an equilateral triangle, students, ध्यान से सुनना students, equilateral triangle में ये ध्यान में रखना, center of mass and center of gravity can be concurrent. And students, ध्यान से सुनना, वो point क्या होगा मालूम है? अगर suppose if I happen to go for where exactly, it will be always a centroid. Students, it will be always a centroid. A centroid is a point, students, which divides the altitude or divides the median in the ratio of what? 2:1. स्टूडेंट्स ये ध्यान में रखना, अगर मैं ये थोड़ा सा मैथ्स ध्यान में रखना स्टूडेंट्स, अगर मैं इक्विलैटरल ट्रायंगल लूंगा ना, एवरीबॉडी लिसन केयरफुली, PQR is my equilateral triangle students. So what is the maths over here is, students यहाँ पे listen carefully students, यहाँ पे अगर मैं perpendicular bisector draw करूँ, अगर मैं यहाँ पे angle bisector draw करूँ, okay, if I'm drawing perpendicular bisector, angle bisector, if I try to draw altitude, if I try to draw medians, divides the base into two equal parts. So students, all these points intersect at one point. And if I try to draw perpendicular bisector of three sides of an equilateral triangle, what is the point of intersection we consider? It's called as the orthocenter. If I try to go for the angle bisector of all the three angles of an equilateral triangle, what is the point of intersection? I'll call this as incenter. This is orthocenter. Okay, sorry, circumcenter, not this is circumcenter. This is incenter. Point of intersection of altitudes is called as orthocenter. And point of intersection of median is called as the centroid. तो students ये ध्यान में रखना, orthocenter, incenter, circumcenter, centroid, G, for an equilateral triangle are all concurrent. एक ही point होगा students. और ये जो point होगा ना, अगर मैं median लेता हूँ students, which divides the base into two, this will be in the ratio 2:1. That's the geometry. अगर ये 2:1 है तो ये कितना टोटल हो जाएगा? 3. ये ध्यान में रखना जब भी MCQs होते हैं स्टूडेंट्स, whenever they ask you for equilateral triangle students. So for an equilateral triangle students, the incenter, the circumcenter, the orthocenter and the centroid are always concurrent. And whenever you go for equilateral triangle, side opposite to 60 degrees is √3/2 times the hypotenuse. Side opposite of 30 degrees is half the hypotenuse. Okay, students. Now, students, let us move further ahead, students. Now, students, we try to go for finding out the center of mass. Students, now we go for center of mass. Okay, for uniform object, students. Okay, uniform rigid object, students. Okay, where the mass is distributed in a continuous manner. Agar suppose मैंने तुम्हें पूछा, students, find locate the center of mass for a rigid body where mass is distributed in a continuous manner. Take a simple example, students. Suppose if I happen to ask the students, I wanted to locate center of mass, okay, students, of a uniform rigid rod, students, जिसका length is L, mass is M. Can you locate the center of mass for such a body? So let us understand that, students. So what I'll do, students, मैं एक uniform mass layer, students. I'm taking a rod of length L, mass is M, and students, the mass is uniformly distributed throughout the length. Let us consider that the rod is placed along the horizontal and consider as x-axis. So अगर मैं suppose उसका center of mass को locate करने के लिए देखूंगा, students, तो ये मेरा कौन सा होगा y-axis और ये कौन सा होगा मेरा x-axis. जहां पे मैंने ये point जो है A और ये जो point B है, ये point A मैं assume कर रहा हूँ origin पे रखा है तो 0,0 है और ये क्या है L,0. क्या ये clear हुआ, students? This is a midpoint of the rod. Students, is the diagram clear to all of you all?
Yes, sir.
मैंने पूछा है find out center of mass for such a uniform rod. Students, अगर मैं center of mass for a uniform rod लूंगा तो कोई भी बोलेगा. ध्यान से सुनो, students. अगर मैं इसको uniform rod बोलूं तो where is the center of mass of this? Sir, it will be at L/2, half the length. Let us try to get this. It's a uniform thin rod we consider. Mass is uniformly distributed. Uniform distribution of mass का मतलब क्या हुआ मालूम है, students? Throughout the length, mass is uniformly distributed. That means, students, mass per unit length is constant. So, समझ में आ रहा है, students? Mass per unit length is constant. Students, what is mass per unit length? Simply be symbolized by variable. We symbolize by variable lambda. If the mass is uniformly distributed, students, we consider mass per unit length remains constant. That is lambda. How is lambda defined as? Students, lambda is defined as mass per unit length. What is the total mass of the rod? Is capital L. What is the length we consider is capital L. Can you give me mass per unit length का unit? Kilogram per meter. अगर ये rod का length meter में है, mass kilogram है, तो what is the unit? Kilogram meter inverse. Or it can be gram centimeter inverse. Yeah, gram millimeter inverse. That depends on to what exactly. But M is total mass, L is a total length. This is also called as linear mass density. ध्यान से सुना, students, जानबूझ के such kind of statements will be given in multiple choice question. The linear mass density of a thin uniform rod is, listen carefully, in a question what they'll give you, the linear mass density of a thin uniform rod is 2 gram centimeter inverse. जैसे तुम्हें ये वैल्यू दी तो तुरंत तुम्हारा यूनिट पे कॉन्सेंट्रेशन होना चाहिए. The linear mass density, उसका मतलब अरे हाँ सर लैम्बडा दिया है, यानी सर कैपिटल M by L दिया है 2 grams और लेंथ 1 सेंटीमीटर दिया है और ये यूनिफॉर्मली डिस्ट्रीब्यूटेड है, यानी M by L मिल गया तुम्हें. क्या ये पार्ट क्लियर हुआ सबको? सबसे पहले is it clear?
Yes, sir.
Now we try to find out center of mass. Center of mass for such a uniform rod, students. So to get the center of mass, students, what do I do? हम क्या करते हैं स्टूडेंट्स, इसी रॉड के अंदर मैंने एक एलिमेंट मास लिया स्टूडेंट्स, एक छोटा सा मास लिया स्टूडेंट्स. लेट अस से दैट पर्टिकुलर स्मॉल एलिमेंट आई एम पुटिंग इट ओवर हियर. यानी इसी रॉड का मैंने एक छोटा सा एलिमेंट लिया, इनफाइनाइटेसिमल एलिमेंट, इतना सा एलिमेंट, छोटा सा एलिमेंट. So that particular element, if you see over here, which I've taken it over here, has length dx it has a mass dm. So students, can you tell me the mass per unit length for this particular element? So sir, mass per unit length for this element also should remain constant. Yani lambda is actually for the entire rod. Can I say the same lambda can be considered for dm by dx also? This is called as uniform distribution of mass. Yani mass is distributed throughout whatever part you remove it from that particular. Jitna mass loge correspondingly, if I try to go for the length, the ratio all the time remains constant. So now what am I getting? Lambda is equal to capital M by L, which is equal to dm by dx. Kya itna clear hua, students? Students? I've taken
Yes,
an
sir.
element dm, jiska length dx hai. Let us say that this particular element, let us say that this element, ye iska center of mass hai element ka. Let us say that this particular element is from the origin x. तो मुझे बताओ स्टूडेंट्स, इसके जो कोऑर्डिनेट्स है ये 0,0 होंगे, गॉट इट? इसके कोऑर्डिनेट्स क्या होंगे सर? इसके कोऑर्डिनेट x, 0. ये मैंने x और y के हिसाब से लिया स्टूडेंट्स, x और y. अगर सपोज मैंने थर्ड एक्सिस भी दे दिया स्टूडेंट्स, ये देखो ये x एक्सिस, ये y एक्सिस. स्टूडेंट्स अगर मैं थर्ड एक्सिस पे लेता हूं तो इज माय एलिमेंट अलोंग द थर्ड एक्सिस? नो, नॉट एट ऑल. लुक एट माय थर्ड एक्सिस. दिस इज माय थर्ड एक्सिस. व्हाट इज माय थर्ड कोऑर्डिनेट? 0,0,0. यहां पे मेरा थर्ड कोऑर्डिनेट क्या होगा? 0. डजंट मेक एनी डिफरेंस स्टूडेंट्स. यानी अगर तुम सेंटर ऑफ मास फाइंड आउट करोगे ना ये रॉड का, तो तुम्हें सिर्फ एक्ससीएम ही मिलेगा. तुम्हारा वाईसीएम और जेडसीएम क्या होगा? 0. आर यू गेटिंग स्टूडेंट्स? I want to find out center of mass of a thin uniform rod of mass capital M, length capital L. So what exactly center of mass I'll consider? So the center of mass will be only with respect to x axis. क्यों? क्योंकि मैंने रॉड को x axis में रखा है. स्टूडेंट्स साउथ को मूड हुआ, साउथ जो है अपने ग्रुप में, उसको मूड हुआ कि सर आपने एक्स एक्सिस पे रखा है, मुझे एक्स एक्सिस पे नहीं रखना है, मेरे रॉड को ऐसे रखा है. और ये मेरा एक्स एक्सिस ले रहा, साउथ ने इसको वाई एक्सिस ले लिया, तो कोई प्रॉब्लम नहीं ना, तो उसको वाईसीएम मिलेगा. लेकिन एक्ससीएम और यहाँ पे भी आंसर L/2 आएगा, मुझे भी L/2 आएगा, मेरा भी सेंटर ऑफ मास L/2 होगा, इसका भी सेंटर ऑफ मास L/2 होगा. लेकिन यहाँ पे कोऑर्डिनेट्स क्या होंगे? 0, L/2, 0. मुझे आंसर क्या मिलेगा? मुझे फाइनल आंसर क्या मिलेगा? L/2, 0, 0. क्योंकि मेरा x के हिसाब से लिया मैंने. Students, are you getting it? How am I trying to find out the center of mass with respect to the three coordinates? Because I've placed my rod horizontally. South has placed the rod vertically. Somebody will keep it along z-axis. तो हम y-axis के हिसाब से नहीं जा रहे, हम x-axis के हिसाब से जा रहे हैं. This particular element I've placed it at a distance x from the origin, not giving the corresponding coordinates. Students, now if I happen to ask you what exactly dm will be, then what exactly dm will be, sir? Dm will be equal to capital M by L into dx. Now let us find out the center of mass, students. Center of mass of this particular element we consider, students, with respect to xcm. So can I say position of center of mass with respect to x-axis will be what? Is the mass continuously distributed? हाँ sir, continuous distribution है. Continuous distribution है, discrete में नहीं है, तो algebraic sum नहीं आएगा, integration आएगा. Do you recollect, students? When there is
Yes, sir.
continuous distribution of mass, how do you find out xcm? तो तुम क्या बोलोगे? dn into x upon total mass we consider. This can I say integration of dm. ये कहाँ से क्या होगा? Sir, you are integrating it from where to where? Where x is equal to 0 to x is equal to L. ये तुम्हारे limits आ गए. ये क्या होगा? 0 to capital M. Students, are you clear with this center of mass with respect to x-axis? Students? Students,
Yes,
अगर
sir.
यही discrete manner का formula क्या है? Students, what is discrete manner का formula? Mi(xi), summation of mi(xi) where I equal to 1 to I equal to n. ये लेते हो ना? तो उसके जगह मैंने क्या लिया? Element मैंने dm लिया. What is the distance of this? X. This is x. because the mass is in continuous manner. Now, can you find out? Yes. Let us solve this part of it now. Solving this, what am I going to get it? So dm can I write down as m by L. This is dx, so it's x into dx. Integration from 0 to L upon integration of dm will be m, and that will be simply capital M. Can I remove the constant terms outside? Yes, sir. Capital M बाहर आ जाएगा. ये L डिनोमिनेटर में आ जाएगा. ये M ऑलरेडी है. इंटीग्रेशन ऑफ क्या हो जाएगा सर? इंटीग्रेशन ऑफ x into dx हो जाएगा 0 to L. So what is integration of x into dx?
X square by 2.
X square by 2. Can I put the limit, students? So what exactly x cum will be equal to what? This m and m will get cancelled. Agreed? So 1 by L bracket close. Integration of x into dx will be what? X square by 2. Lower limit is 0. Upper limit is capital L. So can I say 1 by L? Can I put this as L square by 2 minus 0? This and this will get cancelled. What's my x cum? L by 2. If x cum is L by 2, what is y cum? What is the formula for y cum? What is the formula for z cum? It's integration of what? Y into dm upon capital M. Integration of z into dm upon capital M. But students, did I align my rod along y and z? No. There's no mass distributed along y-axis. Students, there is no distribution of mass along z-axis. So what exactly ycm and zcm will be simply 0. So now can you tell me what exactly the center of mass of a uniform rigid rod of length L and mass n? What exactly your center of mass will be? L by 2, comma 0, comma 0. So can I say it's actually the midpoint of the rod? Are you getting this, students?
Yes, sir.
Students, अगर मैं चाहता हूँ सीधा मैं बता देता, अगर मैं कोई थिन यूनिफॉर्म रॉड देता हूँ जिसका लेंथ L है, students, so where is the center of mass of this? तो मैं सीधा बताता L by 2, half. Because center of mass is the point where the entire mass of a body is supposed to be concentrated. वही अगर मैंने वेट के हिसाब से ले लिया तो वो सेंटर ऑफ ग्रेविटी होगा, लेकिन उसको प्रूफ करके लेके आया तो बाय इंटीग्रेशन आई एम सेलेक्टिंग इट बिकॉज़ द मास इज इन कंटीन्यूअस मैनर. और ये जो डीएम है मैंने यहाँ से शुरू, यानी मैं डीएम को यहाँ से ले रहा हूँ स्टूडेंट्स, और 0 से लगा के कहाँ तक जा रहा हूँ? From here I'm taking it closer, away from away, and finally I'm taking it to what? To L. I'm distributing the mass throughout the length. That's why my lower limit is x is equal to 0, so x is equal to L. Can I erase this, students, now?
Yes,
Students,
sir.
can I erase it? Okay. Students, do keep in mind at times when you're solving MCQs also, students, somewhere or the other, you need to come across with such kind of way of approach, students. Okay. Where over here we are taking it a rod, so the mass is distributed along the length. I can take it as area also, but the mass is distributed along the area, laminar one. Now, since we got the answer for thin rod, likewise we can find out the center of mass for different geometrical shapes, students. So please mention these are the ones which you need to keep in mind, students, for your MCQ's point of view. So center of mass of a thin uniform rod, students. So what's my answer? L by 2. Do keep this in mind, students. Okay. It's at L by 2, students. Okay. Coordinates will be L by 2, 0, 0. I can consider. Now, suppose if I happen to ask you center of mass for a rectangular lamina, okay, a square lamina, or a circular disc. Okay, this is a rectangular lamina, square lamina, circular disc. Friends, can you tell me where exactly the center of mass for these geometrical shapes?
So for the rectangular and square lamina intersection of diagonal.
Yes, point of intersection of the diagonal will be. यानी अगर सपोज मैंने इसको L दिया, ध्यान से सुना स्टूडेंट्स, अगर मैंने इसको L दिया, उसको मैंने ब्रेथ दिया, तो कैन यू टेल मी वेयर इज द सेंटर ऑफ मास? स्टूडेंट्स, व्हाट इज XCM एंड YCM? यानी तुम क्या करोगे, ध्यान से देखना, ये रेक्टेंगल हुआ स्टूडेंट्स, एग्रीड? कैन आई टेक इट अलोंग द X एक्सिस एंड Y एक्सिस? ये क्या है L, ये क्या है B, agreed? Now if I happen to go for the coordinates, what exactly I'll consider this becomes my COM, point of intersection of the diagonal students. आया ना?
Yes.
Yes.
इसके coordinates क्या होंगे students? L/2, comma, agreed? Agreed students?
Yes, sir.
Yes, sir.
Point of intersection of the diagonal students. Whereas if I happen to go for square students, where exactly it will be again point of intersection of the diagonal itself only. Agreed? Over here for square lamina also. For a circular disc, where exactly students? Circular disc for a circular plate. Point of intersection of the diameter, so that's at the center. Over here, it's the center of mass, or center of mass we consider as a point of intersection of what? The diagonals. Over here also COM. Next, if I happen to ask you students for a thin uniform ring, the answer, students, अगर suppose मैंने give दिया, if I ask you center of mass of a thin uniform, students, thin uniform semicircular ring. Then the mass is uniformly distributed, students. So where exactly? So if I try to draw the diagram, students, ध्यान से देखना, ये तुम्हारा semicircular ring हुआ. Students, ये semicircle है. I getting it? This semicircular part, ये तुम्हारा diameter है. I'll consider this as X. I'll take this as Y. So can I say these are the axes of symmetry? ये है center of the ring. तो मुझे बताओ students, center of mass कहाँ पे होगा? Students, center of mass always shifts towards the heavier mass. Where exactly the heaviness you'll come across? Sir, along the circumference, towards the periphery. So students, यहाँ पे अगर तुम देखोगे ना students, there is no such mass distributed along x-axis. Students, the mass is distributed along y we consider. तो यहाँ पे तुम्हारा जो center of mass होगा ना students, for thin uniform ring is where exactly? It's along y-axis. कहाँ पे? Students, कहाँ पे? At a height. At a height. How much? 2r by pi along the axis of symmetry. Students, from the center along the axis of symmetry at a height 2r by pi from the center. ये तुम्हारा center of mass हुआ. किसका? Thin uniform semicircular ring. Students, अगर मैं सिर्फ ring लिया होता ना, मेरा पूरा ring लिया होता तो उसका center of mass कहाँ पे होता? Geometrical center. लेकिन अगर मैंने half ring ले लिया, there is no mass distributed along the x-axis. यानी उसका XCM क्या हो जाएगा? सर XCM तो 0 हो जाएगा. उसका YCM क्या है? सर YCM is equal to what? 2r upon pi. ये तुम्हारा x coordinate, ये तुम्हारा y coordinate हुआ. क्या ये क्लियर हुआ?
Sir, will you show the derivation for this height?
For
that 2r by pi height.
okay. Now if you want to go for it, how do you consider? कैसे करोगे इसको? Students, जैसे मैंने rod के लिए लिया था, exactly try to go for it. Now please pay attention for the derivation part of it. Listen carefully, students. To go ahead with it, am I speaking about, the answers in students, am I speaking about a laminar structure or am I speaking about a thin kind of a wire? Is it a thin kind of a wire or it's a laminar plate kind of it?
Wire.
Yani students, I will not go for area, I will go for length. Kya ye
Yes, sir.
clear?
Yes.
Yes.
So how to begin with your proof? So should you go for, I'm giving you two variables. Students, should you go for linear mass density? Are you getting it? Or should you go for surface mass density? Linear mass density or surface mass density? What should I go for?
Linear
Lambda.
mass density.
Linear mass density.
The mass per unit length. I'll go for lambda. जब भी सपोज अगर यही डेरिवेशन अगर मैं चाहूँ तो मैं दूसरा भी डेरिवेशन तुम्हें करके दे दूं, ये रिंग के लिए सपोज अगर यही क्वेश्चन में चेंज करता और मैंने ये सेमी सर्कुलर पूरा प्लेट लिया, स्टूडेंट चलो ये पूरा प्लेट ले लेते, सॉलिड ज्योमेट्रिकल शेप पूरा प्लेट, तो उसका सेंटर ऑफ मास कहाँ पे होगा स्टूडेंट्स? उसका सेंटर ऑफ मास ध्यान से देखना, अगर मैंने ये सेमी सर्कुलर प्लेट लिया स्टूडेंट्स, यूनिफॉर्म, ध्यान से सुनना, यूनिफॉर्म सेमी सर्कुलर प्लेट, ये सेंटर है, along x axis there is no center of mass, but yes the center of mass will lie along y axis. कहाँ पे होगा? It will be the mass is distributed more towards the periphery we consider. Students, over here you will get the answer as what? It is along the axis, along the y axis at a height of 4r upon 3 pi from center of the lamina. Students, अगर मैंने ये रिजिड लैमिना दिया है, रिजिड लैमिना अगर मैं लेता हूं तो यहाँ पे मेरा सरफेस एरिया किस हो जाएगा, तो यहाँ पे मेरा सेंटर ऑफ मास ये होगा स्टूडेंट, दिस इज माय COM. तो प्लीज स्टूडेंट्स ये भी फॉर्मूला लिख के रखो, अगर मैंने यूनिफॉर्म सेमी सर्कुलर प्लेट ले लिया तो व्हाट एग्जैक्टली माय सेंटर ऑफ मास विल बी? सेंटर ऑफ मास इज एट अ हाइट. नाउ सो हाउ डू यू रिप्रेजेंट इट? सेंटर ऑफ मास फॉर अ यूनिफॉर्म सेमी सर्कुलर प्लेट is at a height of 4 capital R upon 3 pi from the center along the symmetrical axis. So that's your answer. यहाँ पे क्या है? 2r by pi. यहाँ पे क्या है? 4r by 3. Have you put down this answer also, students? ये answer डाल दिया students? Then I'll erase it and I'll go for this derivation for this one. Shall I erase this part? इसको erase कर दो students?
Yes, sir.
Okay. Now students, listen carefully how to go about this, okay? The time we are speaking about for yes, it's a right circular, uniform semicircular ring. Of course. South.
Okay, sir.
It's for that only I'm saying it. Now please let us understand this part of it. I need to get this particular answer. I want to look at the point of center of mass. Students, ध्यान से सुनना. हम क्या करते हैं students? ये देखो, ये तुम्हारा ring है. How to go about students? Okay, this is the horizontal x-axis, center. This is the vertical y-axis, students. Okay. Now what I'll do, students, I will try to go for some element exactly the way I took it for rod. Students, ये सोचो ना, ये अगर मैंने rod लिया होता तो straight होता, उसी rod का भी मैंने bend कर दिया है. Concept remains the same, students. Concept of approach remains the same. सोचो कि अगर वही element, कुछ ध्यान आ रहा है, मैंने यहाँ पे इसको एक end पे दिया था, ये element लिया है, उसका distance from one end मैंने लिया था, अब इसको मैंने bend कर दिया, students. So I have to go with respect to my point O. तो अगर मैं ये bend करता हूँ तो let me take this part of an element. Let us take a small element over here. Are you getting it? I'm taking a very small element. Let us say the element is dx. Its mass is how much? dm, students. Agreed? Now,
Yes.
since the element is very small, can I say it subtends a very small angle at the center? ये जो element है, whose length is infinitesimal, very small length. Mass is also very, very small. But what exactly lambda? Lambda, so lambda is constant. So what about the angle which is subtends at the center? Is it very large or very small? So this angle will be very small. What if this angle I'll consider will be, so this angle I can write down as d theta. ये क्या बन जाएगा? सर ये बन जाएगा मेरा radius of the semicircular ring. क्या इतना clear हुआ सबसे पहले?
Yes.
Yes, sir.
Now let us go for linear mass density, students. What is linear mass density for the entire ring? We consider the means lambda is equal to, let us say the mass of the entire ring is capital M and the length will be equal to L. So can I say it is mass per unit length? Friends, what is length of this particular ring? So the ring is in form of a semicircle. So what exactly the length? Can I say this is
Pi
pi r? I'll consider. Agreed?
Yes, sir.
Now can I say this is also equal to what for the element part of it? What exactly lambda? यानी अगर मैं m upon pi r की value निकालूंगा ना, exactly same answer I'll get it for this part element. What is the mass of this element? dm. What is the length of this element? dx. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
Everyone, क्या इतना सा clear हुआ students? Now let us go for central angle. ये तुम्हारा angle theta है. How do you define? How do you give a, what is the relation between theta, length of arc and radius? Theta, length of arc and radius. Sir, we have learned it in maths as well as sir, you have done it in circular motion also.
Theta is equal to length of
Theta
arc
is
by
equal-
radius.
Yes, and what exactly we learned in circular motion, sir? S bar is equal to theta bar cross r bar. अगर तुम्हें याद आता है, differentiating
Yes,
both the
sir.
sides. Circular motion में जा रहा हूँ. Differentiating both the sides with respect to time. ये क्या बन गया? V bar, omega bar cross r bar. इसी को अगर मैंने suppose अगर V is equal to omega cross r, अगर इसी को मैं वापस differentiate करता हूँ by using product rule, by using, तो मुझे क्या मिल रहा है? Acceleration net मिल रहा था. That is equal to acceleration centripetal plus acceleration tangential. कुछ याद आ रहा है circular motion?
Yes,
Yes,
sir.
sir.
Okay, please. That's why maybe in the next lecture I'll try to pick up the entire part of it to just go for a quick revision so that you can score better. So यहाँ पे देखो lambda is equal to mass per unit length m upon pi r मैंने ले लिया है. Small element के लिए मैंने क्या किया है? dm upon dx ले लिया है. Friends, can you tell me what is the relation between angle length of arc? तो तुम क्या बोलोगे सर? Theta is equal to length of arc upon radius capital R. So can I write on dx as r into d theta, students? Now can I make dm as my subject? ध्यान से देखना, मैं dm को subject बना रहा हूँ. So what is dm? dm will be equal to what? Sir, it's m into dx upon pi r. But what is the dx? What is dx? R into d theta. Can I say rr will get cancelled? Students?
Yes, sir.
तो क्या मुझे मिलेगा? m into d theta upon pi. क्या did you get the value of dm in terms of m into d theta upon pi? Is this clear to all of you all?
Yes, sir.
Now we need to find out what center of mass for a thin uniform ring. तो मैं क्या करता हूँ students? यही r को जो मेरा position vector है students for this particular element. Students ये भी तो मेरा position vector है ना? ये भी तो position vector है ना? So what do I try to? I try to locate this. Let us say that this particular is at an angle theta with the horizontal. Can I resolve this r into two components? Can I resolve this r into two components the way Yana did it for that question? तो ये क्या होगा? सर सिंपल, ये होगा आपका x कोऑर्डिनेट का और ये होगा आपका y कोऑर्डिनेट. यानी स्टूडेंट्स अगर मेरा ये dm, ध्यान से सुनना, ये जो dm है ना स्टूडेंट्स, उसका ये सेंटर ऑफ मास है. लेंथ इज वेरी स्मॉल. तो इसके जो कोऑर्डिनेट्स होंगे, इसके कोऑर्डिनेट्स क्या होंगे? इसके कोऑर्डिनेट्स क्या होंगे? सर इसके कोऑर्डिनेट्स अगर आप लिखोगे तो इसके कोऑर्डिनेट्स तो x, y होंगे. स्टूडेंट्स समझ में आ रहा है?
हाँ, sir.
है ना? तो ये x क्या होगा? सर ये x क्या होगा? सर ये x जो लिखोगे वो क्या होगा? सर x, y फॉर एलिमेंट पार्ट, वो x को मैं क्या लिखूंगा? सर x इज r cos थीटा. y क्या होगा? r sin थीटा. क्या ये क्लियर हुआ सबको?
Yes, sir.
प्लीज अगर ये क्लियर है तो मैं आगे बढ़ूं, अदरवाइज somebody asked me to prove it. Who was that person? Suhani, you said it?
Yes, sir.
Hope you're getting it, Suhani. The rest of the
Yes, sir.
students, don't go to sleep. Don't doze off.
Yes, sir.
Physics. This is physics. Okay, so much जाना. होने वाला है आगे जाके ऐसे ही आने वाले सारे क्वेश्चंस. लेकिन थोड़ा सा अगर तुमने अपने आप को ब्रेन को थोड़ा सा एक्सप्लोर करना शुरू किया तो स्टूडेंट्स विल बी एबल टू क्रैक क्वेश्चंस. In order to crack certain questions properly, you need to understand. तो स्टूडेंट्स हमने एक एलिमेंट लिया है, उस एलिमेंट का जो डिस्टेंस है फ्रॉम सेंटर ओ इज कैपिटल आर. मैंने r को रिजॉल्व किया. दिस इज थीटा, तो ये r cos r sin थीटा. Now suppose students, if I ask you, does this particular center of mass of the same uniform ring, will it be along x axis? No, because there is no mass distributed along x. Students, यानी मेरा xcm क्या होगा? xcm तो जीरो ही होगा. x center of mass तो मेरा जीरो ही होगा. और अगर तुम चाहो तो वो प्रूव भी कर सकते हो. चलो लेट अस प्रूव इट. जीरो आ रहा है कि नहीं आ रहा है? प्लीज एवरीबॉडी लिसन केयरफुली. अगर मैं xcm मैं पहले लिखूंगा फिर मैं इसको इरेज कर देता हूँ स्टूडेंट्स. xcm अगर मैं निकालूंगा स्टूडेंट्स तो कहना है इसे is the mass continuously distributed? Yes. So what exactly the formula is? X into dm. अपॉन इंटीग्रेशन ऑफ dm। एग्री स्टूडेंट्स? यहाँ पे लिमिट्स क्या होंगे? सर ये एलिमेंट को ध्यान से सुनना, ये एलिमेंट को आप 0 से शुरू करोगे क्योंकि थीटा है ना, तो 0 से शुरू करके कहाँ तक जाओगे? सर यहाँ पे 0 डिग्रीज होगा और यहाँ पे पाई डिग्रीज होगा, तो 0 to पाई पे जाओगे। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
लिमिट समझ में आ गया? लिमिट समझ में आया? Please, it's
Yes,
it's a
sir.
thin wire. It's a thin wire which is bent in form of a semicircle. So this element को अगर मुझे limits देना है तो ये element को मैं कहाँ से place करना शुरू करूंगा? तो मुझे सर ऐसा कहता ना, ये element को पहले हम यहाँ से शुरू करेंगे और फिर उसको किस तरफ लेके जाएंगे? उस तरफ लेके जाएंगे। Our ring is having no mass distributed along x-axis, but then towards I'm taking it. My answer is 0. How do I get it? Let us go for this. अभी देखो mathematically prove करते हो. What is x coordinate for this particular? The x coordinate will be r cos theta. ध्यान से देखना स्टूडेंट्स, तो x की जगह पे ध्यान से देखना स्टूडेंट्स, कैन आई राइट r cos theta? हाँ स्टूडेंट्स, dm को मैं क्या लिखूंगा? dm को क्या लिखूंगा? सर dm को आप लिख सकते हो m into d theta upon pi. हाँ स्टूडेंट्स,
Yes, sir.
ये पूरा किस में आएगा? इंटीग्रेशन में आएगा, आया ना?
Yes, sir.
अपॉन कैपिटल M. एग्रीड?
Yes, sir.
अभी यहाँ पे देखो, इस कैपिटल आर कांस्टेंट? हाँ सर। इस पाया कांस्टेंट? हाँ सर। इस कैपिटल M इस कांस्टेंट? यस। स्टूडेंट्स, कैन यू टेल मी व्हाट इज इंटीग्रेशन ऑफ cos थीटा इनटू d थीटा? व्हाट इज इंटीग्रेशन ऑफ cos थीटा d थीटा? फास्ट एवरीवन,
Sin theta.
कैलकुलेट डन। एब्सोल्युटली करेक्ट, sin थीटा। Students, integration of sin theta d theta will be minus cos theta. Integration of cos theta d theta will be
Sin theta.
limits क्या होंगे? Students, what is sin of 180? What is sin of 0? What is my answer?
Zero.
अभी 0। समझ में आया? ये मैथमेटिकली प्रूव हो गया। Are you getting, students?
Yes, sir.
इसलिए हम दिखाते नहीं स्टूडेंट्स, whenever teachers try to throw these things across to you all, they'll say there is no center of mass along x-axis. I get the center of mass is along y-axis. The plate is not along z-axis. Also we consider the plate is placed in an xy plane, but over here there is no center of mass. There is no mass distributed along the x-axis. It's all we consider it's in a y plane only. The mass is distributed on a y plane itself only. तो तुम्हारे ये तो 0 हो गया. Can I erase this part? क्या इस part को मैं erase कर दूं?
So one second.
Students, are you all getting it?
Yes, sir.
Aditi
Yes,
getting
sir.
it?
Yes, sir.
Sanjana, what about you, Sanjana?
Yes, sir.
संजना, जबरदस्ती हाँ मत बोलना, अगर नहीं समझ में आता तो पूछ वापस कहाँ पे क्या है. Don't just blindly take it. I'm speaking to those students who reply. Students, I'm sick and tired of students who don't speak at all. In spite of putting my fingers in the mouth, then too also they don't. Suhani, is it clear with you?
Yes, sir.
Okay. Vidhi has said it. Chati, what about you?
Yes, sir.
Okay. Yana को भी मेरे को I have to put my fingers in her mouth. Yana, getting it, Yana?
Yes, sir.
हाँ Yana, समझ में आ रहा है Yana?
हाँ.
फिर इतना भड़क क्यों हाँ बोल रही है? Yana, ऐसा भड़क के मत बोलना प्लीज. अच्छी तरह से हाँ बोलो. समझ में आ रहा है Yana?
Yes.
Okay, fine. Parthi is not there. Parthi, she left the meeting or what?
No, sir, I am there.
Okay, Parthi, समझ में आ रहा है Parthi?
Yes, sir.
Okay, fine. Now students, मैंने जो तुम्हें दिया है वो XCM के हिसाब से दिया था, लेकिन हमें हमारा सेंटर ऑफ मास अलोंग y एक्सिस है स्टूडेंट्स, तो मुझे y कोऑर्डिनेट के हिसाब से लेना है. Got it?
Yes, sir.
So now can I say what exactly is center of mass with respect to y axis, students? What's the formula? So your center of mass with respect to YCM will be equal to what? Integration of y into dm, 0 to pi upon integration of dm, 0 to capital M. Why integration? Because the mass is in continuous manner, students. तो ये तो तुम्हारा कैपिटल M हो जाएगा। ये जो इंटीग्रेशन ऑफ y इंटू dm है, तो y की जगह पे क्या लिखोगे तुम? r sin theta स्टूडेंट्स। व्हाट एग्जैक्टली dm? इट्स m इंटू d थीटा अपॉन पाई 0 टू पाई आ जाएगा स्टूडेंट्स। क्या यहाँ पे मैं कांस्टेंट टर्म्स बाहर निकाल दूं स्टूडेंट्स? हाँ सर, एक कैपिटल R बाहर आएगा। अगर ये m में बाहर निकालता हूँ तो नीचे वाला m के साथ में कैंसिल हो सकता है स्टूडेंट्स, तो मैं वो नहीं दिखा रहा हूँ मैं। पाई डिनोमिनेटर में चला जाएगा स्टूडेंट्स। बचा क्या अंदर? इंटीग्रेशन ऑफ साइन थीटा इंटू डी थीटा स्टूडेंट्स 0 टू पाई। एग्रीड स्टूडेंट्स? क्या ये क्लियर हुआ?
हाँ सर।
Now can you tell me what is integration of sin theta students? तो तुरंत तुम बोल रहे हो सर हम लोग ने बेसिक मैथ्स किया है, तो दैट बी माइनस कॉस थीटा। तो ये माइनस कॉस थीटा लिखूंगा, लोअर लिमिट 0 अपर लिमिट पाई। एग्रीड स्टूडेंट्स?
यस सर।
तो y com, अभी ध्यान से देखना स्टूडेंट्स, r अपॉन पाई। मैंने क्या किया, माइनस साइन बाहर ही लिखता हूँ। कैन आई सब्स्टिट्यूट अपर लिमिट माइनस लोअर लिमिट? तो अपर लिमिट का मतलब क्या हुआ, cos पाई माइनस cos 0। Students, what is cos of pi? -1. Cos of 180 is -1 students. Cos of
Yes,
0
sir.
is 1. यानी ये क्या होगा, ये -1, ये सिर्फ 1 है। -1 कितना होगा, -2। माइनस इंटू माइनस प्लस 2। Am I getting 2r by pi? And that's your y coordinate at a height 2r by 5 from the center. Agreed? यानी ध्यान से देखना स्टूडेंट्स, वायर को अगर मैं स्ट्रेट रखूंगा ऑफ लेंथ L, माय सेंटर ऑफ मास इज L/2। उसी वायर को अगर मैं बेंड करता हूं इन फॉर्म ऑफ अ सेमी सर्कुलर रिंग, वेयर इज माय सेंटर ऑफ मास? इज माय सेंटर ऑफ मास लाइंग इनसाइड द मैटर? नो, इट्स लाइंग आउटसाइड द मैटर। Students, radius is r. Where is exactly my center of mass is 2r by pi. Is it less than r? It's less than r. Yani, where is my center of mass? Its center of mass is inside the hollow space we consider at a height of, कैसे बोलना है? At a height of 2r by pi from the center along the symmetrical axis. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
क्या मैं इसको erase कर सकता हूँ?
Yes.
कोई मुझे प्लेट का आंसर दिखा सकता है जो मैंने फॉर्मूला दिया था? Can you tell me what exactly center of mass for a thin uniform semicircular plate of radius r?
4r by 3 pi.
Yes, 4r by 3 pi. अभी ये स्टूडेंट्स ये सारे फॉर्मूलाज याद रखने हैं। Can anybody derive it, students? चलो सुहानी, can you derive?
Sir, I will try.
हाँ?
I will try.
इसको मैं erase कर दूं students? Can I erase this? Can I erase this entirely?
Yes.
Okay. Okay, Suhani, you can get me the answer. You solve it and then just send me on my personal chat, okay? Personal chat पे भेज देना करके, okay?
Yes.
Fine, students. Now see, that was for ring. फिर हम semicircular plate का भी मैंने formula दे दिया students, okay? So do take care of it. अगर suppose मैंने पूछा what is the center of mass for a solid hemisphere, okay? अगर suppose मैंने एक solid hemisphere दिया, students ये भी formula ध्यान में रखना. Not a sphere. Sphere तो will be geometrical center. लेकिन अगर मैंने सॉलिड हेमिस्फीयर दिया स्टूडेंट्स, this is solid hemisphere students, of radius capital R students. Okay, radius is capital R students. So where exactly a center of mass we consider is, since इसका जो सही ध्यान रखना, center of mass for a solid hemispherical surface students. तो इसका center of mass कहाँ पे होगा? At a height of how much? 3r/8. Where? On the symmetrical axis. With symmetrical axis, I'm taking it along y. Since it is at a height of 3r/8 along which axis? Symmetrical axis. और ये क्या है? Solid hemisphere. Agreed? Solid hemisphere. जिसका रेडियस क्या है? कैपिटल आर. क्या ये क्लियर हुआ स्टूडेंट्स? ये भी एक फॉर्मूला ध्यान रखना स्टूडेंट्स. Now try to solve this question students. The answer is enough. The question is students. Listen carefully. What is the question? The question is a rod of length L is placed along x-axis. A rod of length L is placed along x-axis. The linear density of rod varies with distance. The answer is students. Linear density of rod varies with distance along the x-axis, distance x. How does it vary? The linear density of the rod varies with distance x from origin, and it is expressed as lambda is equal to, since it is expressed as lambda is equal to a plus bx, where a and b are constant. मेरा question है students, find COM of the rod. क्या ये question clear हुआ students? A rod of length L, उसको कहाँ पे place किया है? X axis पे किया है. उसका जो linear density of the rod है, यानी lambda जो है, with distance x, okay, from origin, it varies with respect to distance x. What kind of variation it is? वो variation को तुम solve करोगे तो एक expression मिल रहा है. यानी students, lambda is a dependence of x. And how does it depend? Lambda is equal to a plus bx, where a and b are both constants. Okay. The question asks us to find out center of mass of the rod. Is the question clear to all of you?
Yes, sir.
Now I want you to solve this and please use your concept properly. जो मैंने derivation में किया है उसको ध्यान से समझ के, क्योंकि यहाँ पे अभी तुम्हें derivation की support होगी. और जो मैंने thin rod का derivation किया पहले वाला, फिर मैंने सेमी सर्कुलर रिंग के बारे में, उसमें जो concepts मैंने यूज किए वैसे वाला ही concept यहाँ पे यूज करना है, लेकिन ध्यान से करना. और ये rigid uniform rod है, mass is uniformly distributed, यानी किसी भी हाल में स्टूडेंट्स यहाँ पे इंटीग्रेशन आएगा. Solve this part. Is anybody? It's a rod, and the rod is distributed along the length, and it's placed along the x-axis, and varies with distance x from origin. तो students जब इसका diagram तुम draw करोगे, तो of course उसका YCM तो होगा ही नहीं, उसका XCM के हिसाब से ही होगा. ये सोचो ना, ये तुम्हारा rod है students. Okay, it's a uniform rod. Mass is uniformly distributed. This is center. Let me take this as x is equal to 0. ये क्या हो जाएगा? X is equal to L हो जाएगा. Agreed. Exactly the same way what we picked up earlier. So try to take an element over here. Let me take this as an element. Okay, this part is of an element. Okay, this is dx. Its mass is dm, and this particular element is at a distance from the origin, students. Small x. I want to find out the center of mass. लेकिन how is lambda distributed? ये देखो lambda के ऊपर पूरा है students. Students, what is lambda? So lambda is linear mass density. What is lambda? So mass of the entire rod is capital M, length is L. अगर मैं element लेता हूँ तो what exactly element का mass क्या होगा? dm, उसका length कितना होगा? dx. है ना students? जब भी हम center of mass लेते हैं तो do I take dm or capital M? Students, अगर मैं center of mass लेता हूँ तो मैंने xcm का फॉर्मूला क्या होगा? Center of mass with respect to x axis में मिलेगा ना? y axis तो 0 होगा, z axis 0 होगा, क्योंकि मैंने rod को कैसे प्लेस किया है? Students, the rod is placed along
along
with
the x-axis.
x axis, तो मेरा ycm और zcm तो 0 ही आएगा. So what is the formula for xcm? तो तुम क्या बोलोगे सर? Integration of what exactly I'll consider will be? So integration of x into dm upon integration of dm. Agreed students? Are you clear?
Yes, sir.
और यहाँ पे तुम्हारा ये जो होगा लिमिट्स क्या होंगे सर? स्टार्टिंग फ्रॉम ओरिजिन स्टूडेंट्स, सो इट्स फ्रॉम 0 to L. यहाँ पे भी तुम्हारा 0 to L होगा. स्टूडेंट्स यहाँ पे इंटीग्रेशन ऑफ डीएम कैपिटल एम नहीं होगा. क्यों नहीं होगा? क्यों नहीं होगा? रीजन क्या है सर? देखो ना, आप डीएम को अगर सब्जेक्ट बनाते हो, ध्यान से देखना स्टूडेंट्स. व्हाट इज डीएम? व्हाट इज डीएम? सर डीएम विल बी लैम्बडा इनटू डीएक्स. एंड स्टूडेंट्स, हाउ इज लैम्बडा डिपेंडेंस with x? तो लैम्बडा की जगह क्या लिखोगे स्टूडेंट्स? a plus bx into dx. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes.
Yes, sir.
नाउ कैन यू सब्स्टिट्यूट ओवर हियर? ध्यान से देखना, ये x वैसे ही रहेगा, dm की जगह तुम ये सब्स्टिट्यूट करोगे. एग्रीड? हाँ स्टूडेंट्स,
Yes.
डिनोमिनेटर में भी dm को क्या सब्स्टिट्यूट करोगे? एग्रीड? Is it integration in numerator and denominator? Yes. Do you know the formulas for integration? Yes. Integration of u plus v method आएगा, नीचे भी u plus v method आएगा. सेपरेटली दोनों को इंटीग्रेट करके सॉल्व करो. लिमिट्स दिए हुए हैं, हाँ सर 0 to L है, क्योंकि दोनों केस में x आ रहा है. यहाँ पे भी x आएगा, यहाँ पे भी x आएगा. Can you get XUL? This is a multiple choice question, students. So क्या करोगे इसको तुम? Integration of x into dm. So x into what is dm? I'll consider will be, sir, x into a plus bx into dx. Lower limit is 0, यानी x is equal to 0 to x is equal to L divided by integration of dm. यानी integration of क्या होगा? a plus bx into dx, where x is equal to 0 to x is equal to L. क्या स्टूडेंट्स अभी इसको तुम सॉल्व कर सकते हो कि नहीं? हाँ स्टूडेंट्स, बेसिक मैथ्स में इंटीग्रेशन किया है कि नहीं किया है? अभी सॉल्व करो, गेट द आंसर. Yes, anybody who can answer, students? Parthvi, can you answer, Parthvi? Parthvi, are you there? He's not there. Very good. Very good. Parthvi.
Yes, sir.
कहाँ भाग रहे हो तुम? आंसर करो अभी इसका, चलो कैसे करोगे? पहले बताओ, समझ में आया प्रॉब्लम? हाँ, the mass is distributed along the length and the linear mass density is expressed as A plus Bx. That's what they've given to you. The rod is placed along the x-axis starting from origin to length L. So lower limit is x is equal to 0 to x is equal to L. Now can you solve this? What is integration of x into bracket A plus Bx into dx to be? और फिर क्या करोगे इसके लिए? तो देखो सेपरेटली करो ना. XUM क्या हो जाएगा स्टूडेंट्स? ये देखो, integration of x into dx into a, तो कहना इसे a into x into dx हो जाएगा. ये मल्टीप्लिकेशन होगा तीनों का. ये क्या होगा सर? bx into x, तो प्लस इंटीग्रेशन ऑफ bx स्क्वायर into dx. क्या ये क्लियर हुआ स्टूडेंट्स? u plus v मेथड. लोअर लिमिट क्या है? x is equal to 0, x is equal to L, x is equal to 0, x is equal to L. डिनोमिनेटर क्या है तुम्हारा सर? ये भी स्प्लिट होगा. इंटीग्रेशन ऑफ क्या होगा सर? a into dx होगा. ये this is a into dx, x is equal to 0 to x is equal to L, plus integration of b into x into dx, where x is equal to 0 to x is equal to L. क्या अभी इसको सॉल्व करने नहीं आता तुम लोगों को? हाँ स्टूडेंट्स, भूल गए? कैलकुलस का शीट्स भेजूं, असाइनमेंट भेजूं वापस, दूसरा असाइनमेंट? हाँ स्टूडेंट्स, स्टूडेंट्स
Sir,
ऑफ नीट. यस, बोलो. Who was answering something? Someone was saying. Suhan, you were saying something?
no, sir, I was saying that I got the answer, but I'm not understanding one thing that in the denominator that dm that you have taken. So why don't we have to take it from 0 to m?
My dear, the reason is why, because your mass is, your mass is distributed with respect to linear mass density, and it is with respect to length a plus bx. Read the question. A rod of length L is placed along x. कहाँ पे भी मैंने बोला है a rod of length L and mass capital M?
No, sir.
Agreed. ये एक पॉइंट ध्यान में रखना. पहले केस में मैंने L और M दिया था. यहाँ पे मैंने क्या है? Rod of length L is placed along x-axis. Linear density of the rod varies. यानी the mass is distributed throughout the length with respect to distance x from origin, and it is expressed as a plus bx. तो स्टूडेंट्स मैंने क्या किया मालूम? मैंने dm को m तो लिया ही नहीं, क्योंकि मुझे ये दिया ही नहीं था. मुझे सिर्फ l दिया था, तो मुझे dm को m से लेना ही नहीं है, मुझे लैम्बडा से लेना पड़ेगा. और लैम्बडा है क्या? a plus bx. क्या ये क्लियर हुआ?
Yes, sir.
Yes, sir.
Now when I solve it, students, what is the answer for this? I'm getting it. So if in case if we're solving it, sir, this is a will be a constant. Integration of x into dx will be equal to x square by 2. Lower limit is 0, upper limit is L, plus b bar आएगा. Integration of x square into dx will be equal to x cube by 3. Lower limit is 0, upper limit is L, upon ये a bar आएगा constant. Integration of dx will be simply x 0 to L, plus b bar आ जाएगा. What is integration of x into dx? x square by 2 0 to L. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Now when you solve it, can you get the answer? Yes sir. XUM का आंसर you can get it यहाँ पे. Please if you try to look into it, students, substitute this L और 0. 0 के लिए तो 0 आएगा स्टूडेंट्स. तो ये आंसर क्या होगा? ध्यान से देखना. A L square by 2 plus B L cube by 3, है ना? ये न्यूमरेटर हो गया, डिवाइडेड बाय A into L plus B L square by 2. Can you solve this and get the answer, students? So solve this and get me the final answer. You'll get the final answer as students 3AL plus 2BL square upon 6A plus 3BL. Please get to the final answer, all of you. Yes, anybody who's got the answer, please post your answer. See, this is a problem with the students. Last 15 minutes left. Students have started going away. Home is still there. Saud आज भी है, क्या बात है? Okay, those different students who entered in late, they have gone out. Gauri is also over here. Vishwakarma, Sparsh is over here. Khyati is over here. There's one Vidhi. Vidhi Paul is not there. Vidhi Paul bhag gayi. Vidhi Parmar is inside. Doesn't matter. Now students erasing the question. Students final answer में लिख रहा हूँ यहाँ पे. How do you go about the final answer, students? So HCM will be equal to students. अगर इसका तुम LCM लोगे तो ये क्या होगा तुम्हारा 6 हो जाएगा students. So that will be equal to how much? A denominator is 6.
So it will be equal to 3AL square
3AL square
plus
plus
2BL cube
okay
upon 6 into
into
2 upon 2AL
yes
plus BL square.
very good. तो ये क्या आएगा 2 3 सा cancel हो जाएगा students. Can you remove L common outside?
Yes, sir. L
Yes,
square
sir.
common, sir.
यहाँ पे L square तुम निकालोगे लेकिन एक L बचेगा ना, यहाँ पे भी तो L है ना, तो एक
तो
ही L
L
निकालो ना.
निकालेंगे.
L ही निकाले. ओके तो अगर मैं एक L निकालूं स्टूडेंट्स यहाँ पे, तो L अगर मैंने बाहर निकाल दिया तो अंदर क्या आ गया स्टूडेंट्स? It's 3AL plus 2BL square है ना,
हाँ सर.
अपॉन ये L मैंने बाहर निकाल दिया तो 3 into ये पूरा ब्रैकेट में स्टूडेंट्स, तो 3 2 जा 6A plus 2BL. Okay, this will get cancelled. This is your answer. ये तुम्हारा क्या होगा स्टूडेंट्स? XCOM. अगर मैंने पूछा व्हाट अबाउट XCOM, YCOM, ZCOM तो 0,0.
0.
Agree students?
Yes, sir.
Yes, sir.
Hope it's clear to all the students. Students, ध्यान से सुनना. Many students they cry onto this particular chapter system of particles. So till the now we have done about discrete particles. Now we are doing continuous particles के ऊपर हम लोग ने किया है. We did integration. We derived certain expressions for a rod also, for a ring also, for such kind of objects we are speaking about. Now when you move further, students will be speaking about a particle in motion. तो जब भी पार्टिकल इन मोशन होगा तो उसका सेंटर ऑफ मास विद रिस्पेक्ट टू इट्स वेलोसिटी, मोमेंटम, एक्सेलरेशन, फोर्स के बारे में बात करेंगे। जैसे हम ये 4 फिजिकल क्वांटिटीज के ऊपर कॉन्सेंट्रेट करेंगे, वेलोसिटी, मोमेंटम, acceleration, force, then we'll slightly go for numericals based on to that. और वो पार्ट अगर कंप्लीट हो गया then तुरंत we'll go for head-on collisions, we'll go for colliding particles we consider, यानी conservation of momentum में आएगा a part of it. शायद तुम लोग ने रॉकेट्स के भी क्वेश्चंस किए होंगे स्टूडेंट्स, a mass of fuel has been detached, elimination of mass from a given body, तो
Yes.
उसका सेंटर ऑफ मास किस तरफ होता है, तो दैट इज हाउ वी कंसीडर। तो उसके रिलेटेड विल गो फॉर सेंटर ऑफ मास, क्योंकि ये छोटा सा एप्लीकेशन है जो यूज होगा आगे जाके। तो इसमें से कुछ पार्ट विल ट्राई टू पिक इट अप स्टूडेंट्स टू मेक योर रोटेशनल डायनामिक्स क्लियर। ये ध्यान रखना स्टूडेंट्स, नीट पार्ट के लिए इतना डेप्थ में नहीं होता है सिस्टम ऑफ पार्टिकल्स, लेकिन some important parts has to be done. You can't miss out completely. You can't eliminate completely. Okay, students? Next lecture will be continuing further from here. Okay?
Okay.
Okay, sir.
Please try to go through all the formulas जो हम लोग ने किए हैं और derive भी किए हैं. Are you getting it? And if someone who wants to solve it for the plate in the next lecture, you can give me an answer in the next lecture also. Okay, students? Let's wind up.